C++ Introduction. This course problem solving using computer. Implementation of the solution using a computer language. Lecture 1 Computer and Programming. What is a computer? Today, computers are everywhere. You're already familiar with calculators. An electronic machine more sophisticated than calculators. A dumb terminal can't think for itself, not pre-designed with any kind of functionality. Consists of two major components. Hardware, software. Problem-solving statement. Calculators are a widely used device nowadays. It makes calculations easier and faster. Calculators are used by everyone in daily life. Program a simple calculator which is able to add, subtract, multiply and divide, two operands entered by the user. Programming. Computers are dumb, but they can do exactly what they're told to do. Giving instructions to a computer to perform a task is what we call programming. These set of instructions are called a computer program. What kind of instructions a computer can understand? How can we communicate with computer language? To write a program for a computer, we must use a computer language. Over the years, computer languages have evolved from machine language to natural language. 1940. Machine language. 1950. Symbolic language. 1960. High-level language. Machine language. In earliest day, only available language. Made of streams of zeros and ones. Because the internal circuit of a computer, which is made of switches and transistors, can be in one of two states, on or off. The off state is represented by 0. The on state is represented by 1. The only language understood by computer is machine language. Problems with machine language. It's very hard for human beings to remember different patterns of zeros and ones. It is almost impossible for a human being to write a computer program consisting only of zeros and ones. There was a need to define a language which is easier to understand and work with. Symbolic languages. In 1950s, Grace Hopper developed the concept of special computer program for converting programs into machine language. Her work led to the use of programming languages that use symbols to represent various machine language instructions. These languages were known as symbolic languages. Today, these languages are also known as assembly languages. Computer can only understand machine language. How symbolic languages will work then? Solution. Assembler. A translator to convert words into appropriate patterns of zeros and ones. i.e., converts series of instructions, written in assembly language, into machine language. Instructions in assembly language, assembler greater than instruction in machine language. Problems with symbolic languages. They are more close to machine rather than human beings. Low-level languages. It is still very different from the languages that human beings speak. It is still difficult for human beings to solve a complex problem by writing a computer program in assembly language. High-level languages. The programming languages which are closer to human languages and further from machine languages. In contrast, assembly languages are considered low-level because they are very close to machine languages. Designed to relieve the programmer from the details of assembly language. Computer can only understand machine language. How high-level languages will work then? Solution. Compiler. A translator to convert instructions written in a high-level language to low-level language. High-level languages are converted to machine language through a process called compilation. See next slide. C++. C++ is a cross-platform language that can be used to create high-performance applications. C++ was developed by Bjarne Stroustrup as an extension to the C language. C++ gives programmers a high level of control over system resources and memory. The language was updated 3 major times in 2011, 2014, and 2017 to C++ 11, C++ 1.4, and C++ 1.7. Apps written in C++. Adobe Photoshop and Illustrator, Spotify, YouTube, Amazon.com, Windows OS, Google, Microsoft Office, MySQL.